So, hello everyone, so we're Team MoodSwing and our topic is lyric mood classification. As the name suggests, our objective is to classify song lyrics into different moods, and the motivation behind the problem is to create better recommendation systems for users. To do this, we first get the data set, which consists of 2,000 song titles and associated artist names, and each of which has a single emotional tag, such as happy, sad, angry, or relaxed. But the problem with this data set is that it doesn't contain song lyrics. So to get the song lyrics, we use an API, just Genius API, which through which we're able to scrape 1721 songs out of the 2,000, and the categories are given as follows. And once we do this, to clean the data, we first remove the extra lines and metadata and also the stop words. Then we go into the stemming and lemmatization. After that, we create a 180 sample manually verified sub-data set, which is used for training. Then here's an example of how our lyrics looks like and the data frame that we have used. For model, we've used the BERT model based on as baseline based on past research, and the GPT-2 model to begin with for improvement. Both of which follow a very similar pipeline where the lyrics are go into the tokenizer, and the tokenized results along with the encoded mood labels go into the pre-trained model, and then in the end we're able to get the class prediction based on that, and further metrics are calculated. The only difference both of them is the tokenizer and the pre-trained model. And then the final improvement that we make is the fine-tuning of using the 3.5 model, where in the 3.5 model the input is slightly different, where we have to give a system prompt, a user prompt that contains the lyrics, and the assistant prompt that contains the mood label for training. So we create the training files in this purpose and in this method, and we're able to get the fine-tuned model. And the prompt that we've used is generated in different sets of prompts, but the one that worked the best for us is where we explicitly state not to retain any previous information regarding the lyrics.
Thank you, Arvind. So moving on, we'll be talking about our results. And to begin with, we have the quantitative results. And the graphs you see here are the training and validation curves of the GPT-2 and BERT model. We see a significant improvement during the training epochs, but the important thing to observe here is that the GPT-2 model seems to overfit. And even though these graphs were instrumental, we needed more information, and that brought us to the classification report. So to begin with, we see that BERT has an overall accuracy of 60%, while GPT-2 gives us an overall accuracy of 54%. And these two models have some similar trends as well, particularly that they both have strong identification of classes happy and angry, but they both perform really bad for classes relaxed. Moving on, we also tested our 3.5 fine-tuned model, and the classification report shows an overall accuracy of 64%, but we also see that all four classes have a more balanced score compared to the previous ones, and a strong identification of angry and happy. Moving on, we also worked on some qualitative analysis. So here you see two examples. The one on the right is a lyrics which has been misclassified. Its true label is happy, but it's been predicted as relaxed. And on analysis, we see that the phrases such as song in my heart, paradise, and the overall soothing tone of the lyrics seem to have contributed to the sense of relaxation. And on the left, you see the lyrics which has phrases such as evil minds, destruction, and an overall contempt for war, eliciting feelings of anger, and this kind of aligns with the correct label. And we also ended up compiling and tabulating the general trends in misclassification, and we see that here the class happy gets misclassified as relaxed the most, sad as angry, angry as sad, and relaxed as happy. So this was interesting to us, and we tried to understand why, and this led us to represent these emotions in the quadrant of valence and arousal. Moving on, we want to discuss about all of these, whatever these were the results that we got. Now, trying to understand these brought us to four interesting findings. The first one being BERT performs better than GPT-2. So we needed to understand why this is the case. And this led us to understand that BERT benefits from bidirectional context understanding, and GPT is a generative model. So BERT is more inclined for classification tasks than a text generation task of GPT. And that might be one reason why BERT seems to perform better here with our lyrical data. And the second one, which was very interesting, was minimal preprocessing gave us better performance than doing a lot of it. And this could be because stemming and lemmatization cannot extract the unique vocabularies out of lyrics in a way that it does with standard text. And that might be one reason why we saw better performance with minimal preprocessing. And moving on, this, as explained before, class relax consistently seemed to be misclassified as happy more than any other classes. And this was interesting. And the one reason why this could be is class relax is a complicated and nuanced concept compared to the other emotions, and it is a little difficult to be defined with special features. And since class relax significantly has similarities with class happy, we feel that the model is having a difficulty in differentiating that. And to dwell a little deeper, we also realize that the model might be inclining towards valence than arousal, and this might be the reason why there's a misclassification as well, because we need both valence and arousal to differentiate between both the emotions. And since the model is inclining towards valence more, it means that it's downplaying arousal, and that might be one reason why we also see these misclassifications. Thank you.